In this unit, we are going to examine an introduction to the terms permutation and combination. With permutations, it is important to note that the order in which the objects are is important because the distinct arrangements of objects are called permutations. For example, 1.1. How many distinct arrangements or permutations that can be made with the three letters ABC? So manually, you would juggle around ABC, you would arrange them in the form of ABC, ACB, BAC, BCA, CAB, and CBA. So this is a simple example whereby you get 6 distinct arrangements. So using the tree diagram to analyze the total number of distinct arrangements that can be made, you can say, for instance, in your first selection, you have 3 choices for your first letter. So when you come to select randomly, you've got 3 choices. Now, after you have select any one of the letters, it could be an A, B, C. Let's say if it's A, you select. When you come back again, you will have 2 letters. So therefore, for each of those 3 letters, you have 2 letters remaining when you come back. And for each of these 2 letters, there is 1 letter when you return again. So the phrase for each can be interpreted as multiplication. So this is why to calculate the total number of arrangements, you have 3 times 2 times 1, which is equal to 6. Because for each of the 3, you've got 2, and for each of the 2, you've got 1. So therefore, there are 6 distinct permutations which can be made with the letters ABC. Hence, the total number of distinct arrangements that can be obtained from 3 distinct objects is 6. Now, to generalize that calculation, the total number of distinct arrangements which can be made with n distinct objects is given by this formula, or you can say this mode of multiplication. First, you start with the total number of distinct objects, then you multiply by 1 less, then you multiply by 1 less of that previous 1 less, so that's 2 times 2 less from where you started, and you go down multiplying descendingly in that manner. And this form of multiplication is called factorial. And the symbol that is used is an exclamation mark. So you can include that exclamation mark as part of your mode of operations in mathematics, apart from adding, subtracting, dividing, and multiplying. Multiplying like this is called factorial, which is denoted using the exclamation mark because it rapidly produces huge numbers or load numbers. Now you have different scenarios for when calculating permutations of distinct objects. So if you are arranging n objects of which p are alike, is n factorial divided by p factorial. If there are more alike, you keep on dividing. So it will be n factorial over p factorial times t factorial. Whatever is repeating is being divided in terms of letters and numbers. Second, if you are arranging n distinct objects in a circle, such as a round table, is n factorial over n, which is n minus 1 factorial. If you are arranging n distinct objects in a circular wire or string, it's n factorial over 2 times n, which can be simplified to n minus 1 factorial over 2. And if you are arranging r objects selected from a total of n distinct objects, that would be n pr, n factorial over n minus 1, n minus r factorial. Now you've got what you call combinations. In combinations, the order in which the objects are is not important. It only concerns with what are there, what are the elements that are present in the set, the combination thereof. So how many distinct selections without replacement, combinations of two letters that can be made from three letters ABC. So manually, you have AB and you have AC. Bear in mind, you are not interested in, and BC, you are not interested in how they are arranged. You are only interested in what are present. So BC and CB would be the same combination. AC and CA, the same combination. AB and BA is the same combination, so therefore there are three combinations of two letters that can be made from the set ABC. Actually, ABC is one combination. If you put ABC and you put BCA, that's the same combination of letters. No matter how you arrangement, the combination of letters are the same. It's an A and a B and a C that is present. No matter how you, in what order you put them, that will be the same combination. In combinations, order does nothing, is not important. So the calculation, you know, it says though, since that the combination, the permutation, the combination has been repeated, so you must divide out the repeated combinations. So that's like NPR divided by R factorial, and that's where the formula for combinations arose. It's N factorial over N minus R factorial divided by R factorial, and that's N factorial divided by R factorial times N minus R factorial. Now the NCR and the NPR button are programmed in your calculators, so you don't have to apply that formula here. But if your calculator does not have the NCR or the NPR formula, for the NCR, you apply this formula, and for the NPR, you apply this formula. N factorial over N minus R factorial, that's the same as NPR. And NCR is NPR divided by R factorial because you are dividing by the repeated combinations, which is R factorial of them. And that simplifies to N factorial over R factorial times N minus R factorial. So take, for example, you want to select without replacement the objects, without replacement where the objects must be distinct, combinations, and you want to select 5 from 12. You want to know how many distinct selections, how many combinations of 5 from a total of 12. So that would be 12C5. Or you can say 12 choose 5. You're choosing 5 from 12 randomly. So there are 792 selections or choices, if you want to put it that way, or combinations of 5 teams from a total of 12 persons. And you can type 12C5 in your calculator, and you can also prove it, that's 792, by doing 12 factorial over 5 factorial times 12 minus 5 factorial to get the same 792. So let's take a closer look at arrangements where the objects must be distinct. It's called permutations. 3 possible approaches can be identified to calculate the total number of different ways a set of n distinct objects can be arranged. A first approach, if you need to calculate the total number of different ways of arranging, permuting n distinct objects, you successively multiply one less value from the previous starting from the number of different values up to 1. And here's the mode of doing that. N factorial is n minus n times n minus 1 times n minus 2 up to times 1. Now, example here it says determine the total number of ways to arrange the letters in the word number, for example. So you've got 6 distinct letters. So you can do a 6 times 5 times 4 times 3 times 2 times 1, which is called 6 factorial, which is 720. Now, if you need to calculate the total number of different ways of arranging or permuting R distinct objects from N, so you're only going to take sum from the total, you can multiply in descending manner R times starting from N. And here you have the formula generalized. Method number 2, you can apply directly NPR. So NPR is programmed in your calculator, or you can do N factorial over N minus R factorial. There's a third method now of permuting R different objects from distinct or N distinct objects, and which is the same as selecting R distinct objects, no replacement, and or then arranging them, the R different objects that were selected. Now, the operation for the word and in statistics, in probability analysis, is multiply. So you are selecting R, or you're choosing R from N, and you are arranging R. Because you must randomly select them, then arrange them. Here we go with the word then, so that this now is interpreted as multiplication when you use the word and in your analysis. So NPR is the same as NCR times R factorial. So take, for example, you want to determine the total number of ways that you can arrange 4 letters from the word number. So the word number has 6 letters in all, but you only want to select R. You only want to select 4, yes, and arrange them. So before the one, you can multiply in descending manner, R times starting from N. So you have 6, that's 1, times 5, that's 2, times 4, that's 3, and times 3, that's 4. And you stop there because it's only 4 you need. So it's 6 times 5 times 4 times 3. And method 2, you can directly apply 6 before, which is equal to 360 in your calculator. Or you can view it as permuting R different objects from N distinct objects is the same as selecting R distinct objects without replacement and then arranging R different objects that were selected. So that will give you 6, choose 4 times 4 factorial, which is the same 360.